The average rate of a reaction is related to the stoichiometry of the reaction, or the stoichiometric coefficients. Let's start by looking at our simple example, molecule A being converted to molecule B. If we wanted to write the average rate of this reaction, we could write it in terms of the loss of reactant A. So the change in concentration of reactant A over time. And again, it's a negative number because we're losing the concentration of B. Or we could write it in terms of the formation of product B, the change in concentration of B over time. And this is a positive number because it's a product it's being formed. When I first introduced you to this A goes to B concept, one of the examples of this type of reaction that I showed you was the Cl2 molecule being converted into 2 chlorine atoms. If we wanted to write the average rate for this particular reaction, we do the same thing. We could say the average rate of the reaction comes from the loss of the Cl2 molecule, the negative change in concentration of the Cl2 molecule over time, or we could write it in terms of the formation of the Cl atoms over time, which again is positive because it's a product. Now, this particular reaction is a little bit more complicated than A goes to B because of the stoichiometric coefficient that we have too. This stoichiometric coefficient is telling us that for every 1 Cl2 molecule, 2 chlorine atoms are formed, which means that the concentration of chlorine is increasing 2 times faster than the concentration of Cl2 is decreasing. In order for us to keep these two expressions mathematically equal to each other, we are going to need to divide the Cl term by 2. We're going to need to take into consideration that it's being formed twice as fast as Cl2 is being consumed. In general, the stoichiometric coefficients always belong in the front of our expression for average rate. So let's just write a generic reaction. Let's say little a, big A, plus little b, big C, forms little d, big D, and little e, big E, where the little letters are the stoichiometric coefficients and the big letters are the molecules. And if we wanted to write the average rate for any type of chemical reaction, we're going to say for our reactants, it's going to be a negative number, and it's going to be 1 over the stoichiometric coefficient times the change in concentration for that reactant over the change in time. Could also be negative 1 over little b, the stoichiometric coefficient, times the change in concentration of molecule B over the change in time. For our products, positive, because they're products, 1 over the stoichiometric coefficient times the change in concentration over the change in time, or 1 over the stoichiometric coefficient little e times the change in concentration of molecule E over time.